Hi, this is Bailey, and now we're going to see how we're going to use fraction models to determine if each fraction is equivalent to one another. So in the first fraction, we see a number line, and to determine a fraction from a number line, we count how much it is broken up, and that is how we can find the denominator. So in this one, it is broken up into 1, 2, 3, and 4 spots. So which will give us 4 in the denominator. And then to determine the numerator of 1, we look at how much it has jumped, which would be 1, 2, and 3, which gives us 3/4. Now to determine if it's equal or equivalent to the circle fraction, we do the same thing and find out what this fraction actually is saying. So we look at the fraction and we count how many spaces in order to find out the denominator. So there's 1, 2, 3, and 4. And now we count the shaded region of it in order to find the numerator, which is 1 and 2. Now, we have 2/4 in this one and 3/4 in the number line model, which those are not equivalent to one another. So we can make this one equivalent to the number line. All we just have to do is just shade in one more region. And now we have 3/4 here, and now we have 1, 2, 3, 4 at the bottom, and 1, 2, 3/4 in the circle, which are both equivalent to one another. Now let's go on to another model. So same thing, we count to see how many are within the circle to find out our denominator, which is 1, 2, 3, 4, 5, 6, and 7. And now we count how many are shaded, which is 1, 2, and 3, which is our numerator. And now for the number line, we count how much it is broken up into, which is 1, 2, 3, 4, 5, 6, and 7 at the bottom. And now we count how much has jumped, which is 1, 2, and 3 as our numerator at the top. Now we have 3/7 for our circle model and 3/7 for our number line model, which are equal to one another. Now let's try making them from a given fraction. So we are given 4/5. So let's draw the circle model first. So, of course, given the name, you have to draw a circle in order to have it. So there, a circle. So now we have to split up into 5 parts since it has given us the denominator of 5. So there's 1, there's 2, there's 3, there's 4, and then there's 5. So let's double check. There's 1, 2, 3, 4, and 5. Now in order to show the 4 of the numerator, we shade in 4 of those sections. There's 1, there's 2, there's 3, and there's 4. So that shows us 4/5. Now for a number line model, first we draw a number line. We start off with 0 and we break it up into 5s. There's 1, 2, 3, 4, and 5. I put a 1 there because 5/5 equals 1. And there's 1, 2, 3, 4, and another 5. I put a 2 there because it's 2/5, which equals 2. Now to say it went 4/5, we start here and count 4 jumps. So it's 1, 2, 3, and 4, which ends here. So it jumped all the way right there. to show that it went 4/5. Now, are these two equivalent? Yes, because 4 of these circle sections are colored in, and there's 5 total. And this, on the number line, it went 4 jumps out of 5.